free radical. This is CH3Br. Using this is homolytic fission and plus Br free radical. This is homolytic fission because molecules break down by taking its own electrons and get separate. So homolytic fission, there is no change in number of electrons in bromine radical, so that's why A option is correct. Not heterolytic, homolytic same 36, no change in number of electrons. So heterolytic, no heterolytic and no change in electrons, so that's why A option is correct option. In this question, which equation represents a valid propagation steps in the chlorination of ethane? So this is the valid propagation step in chlorination of ethane because over here hydrogen become the free radical, which is not in the free radical substitution reaction, and this is also hydrogen radical is not formed in propagation step, so this is also incorrect. So these are not propagation, this is termination step, so that's why termination step, so A option is correct option. Next question is, most modern cars are fitted with catalytic converter in the exhaust system. Which three gases are removed by catalytic converter? Catalytic converter removes carbon monoxide, unburnt hydrocarbon and oxide of nitrogen. NOx, which can be nitrogen monoxide or nitrogen dioxide. So the first option, carbon monoxide can be removed, hydrocarbon can be removed, nitrogen oxide can be removed. In second option, carbon monoxide can be removed, carbon dioxide cannot remove, nitrogen oxide can be removed. So this is incorrect. Carbon monoxide removed, oxide of nitrogen can be removed, sulfur dioxide cannot remove by using catalytic converter. Hydrocarbons can be removed, oxide of nitrogen can be removed, this can be. So A option is correct option. Next question, which statement about the use of alkane fuels in internal combustion engines is correct? H18 is used as a fuel in internal combustion engine and react with oxygen. Alkane fuels in internal combustion engine is correct. H18 is used as a fuel in internal combustion engine and react with oxygen and nitrogen from the air. In limited oxygen, carbon monoxide is produced. In limited oxygen, carbon monoxide produced, which oxidizes sulfur dioxide. Now this is incorrect. Catalytic converter removes pollutant gases. Nitrogen dioxide can be removed but carbon dioxide cannot. Unburnt hydrocarbons and nitrogen dioxide can react in sunlight to produce photochemical smog. Yes, this is correct option. Unburnt hydrocarbon and nitrogen dioxide can react in sunlight to produce photochemical smog. Many reactions take place in the in the engine and catalytic converter of car. Which pair of substances is produced both by reactions in a car engine and catalytic converter? Carbon dioxide and unburnt hydrocarbon. Carbon dioxide cannot produce in car engines. Unburnt hydrocarbon, it can be produced. Carbon dioxide and water in car engines and in catalytic converter. Carbon dioxide can be produced in car engine as well as in catalytic converter. Carbon monoxide and nitrogen in catalytic converter, not in catalytic converter but in combustion engines. Carbon monoxide and unburnt hydrogen only in car engines, not in catalytic converter. So B option is correct option. At 550 degrees centigrade, nitrogen dioxide react with the unburnt hydrocarbon fragments such as CH3 in the catalytic converter of a motor vehicle. At 550 degrees centigrade, nitrogen dioxide react with unburnt hydrocarbon fragments such as CH3 in the catalytic converter of a motor vehicle. Which row gives the energy change for this reaction and a possible reason for it? So this is methyl plus nitrogen dioxide to form nitrogen, carbon dioxide and water. Energy change endothermic. This reaction reacts with unburnt at 550 degrees centigrade such as CH3 in catalytic converter of a motor vehicle. So this is not in chemical energy is converted into heat energy. So this is not endothermic, and chemical energy is converted into heat energy. This is correct. Endothermic, not endothermic, nitrogen bond energy is very high. This is endothermic reaction, bond energy is very high. So this is also incorrect. Exothermic, yes, this is correct. Carbon dioxide and water have negative delta H formation values. Yes, this is correct. Exothermic double bonds are broken in nitrogen dioxide. No, this is not correct. Bond breaking is endothermic and bond forming is exothermic, so that's why C option is correct option. Next question is alkanes are saturated hydrocarbon. Which type of reactions are alkanes mostly likely to undergo? Electrophilic addition. Alkanes mostly likely this electrophilic addition. Alkenes exhibit electrophilic addition, so there is no electrophilic addition in alkanes. Electrophilic substitution, so there is only free radical substitution. Electrophilic substitution is not possible with alkane. Free radical substitution is correct option because alkanes undergo only free radical substitution, so not nucleophilic addition. So C option is correct option. So next question is which fuel would produce the largest mass of carbon dioxide when 10 kg of the fuel undergo complete combustion? So percentage of carbon is 204. This is we have 17 carbon, 12 into 17, it is 204, and 270 is the molecular mass MR of compound into 10 kg. So this is 7.56, and in this case in ethanol 24/46, because carbon is 24 and the 46 is the MR of compound out of 10 kg. So this is 5.22, and in this case 96 divided by 14 into 10 is equal to 8.4. 8.4, and in this case 8.18. So in this, C option is correct option. Undergo largest mass of carbon dioxide. Which equation represents a valid propagation step? This is I have discussed earlier. So B option is correct. This is repeated question. So this option is correct option, because hydrogen is not part of propagation reaction. Hydrogen is not a propagation reaction. This is termination, and this is also hydrogen. So this option is correct option. Next question is, which equation represents the initiation step of the substitution reaction between methane and chlorine? CH4 is not going to break initially, so this is not initiation step of the chlorine. Chlorine is going to break down, halogens are going to break down for initiation. So this is the correct option. So this is also incorrect. Cl2 cannot break down to form Cl positive and Cl negative. Next question is, the first propagation step in the reaction between methane and chlorine is shown. How many different first propagation steps are possible in the reaction between pentane and chlorine? So this is pentane molecule, and we have 3 different first propagation steps, because this is 5 carbon compound, and this is first when hydrogen is removed from this, chlorine is substituted in with this carbon. This is, and next can be over here and can be over here. So these are 3 possible propagation steps in the pentane, because then if we remove this, so this is similar to this methyl group, this is similar to this, and this is similar to this. So that's why only 3 possibilities are there. So that's why 3 different first propagation steps are possible in the reaction between pentane and chlorine. Next question is, which stage in the free radical substitution of ethane which stage in the free radical substitution of ethane by chlorine has the lowest activation energy? Cl2 to form 2Cl radical, Cl radical to form C2H6. Free radical substitution of ethane by chlorine has the lowest activation energy. Chlorine when become radical, so it has lowest activation energy because radicals are very reactive species, so that's why it is ethane bichlorine has the lowest so over here ethane has highest activation energy, but this radical has lowest. This chlorine has highest, this chlorine ethyl radical, so D option has both radicals, so that's why both have lowest activation energy, so that's why D option is correct. Next question is when heated with chlorine, the hydrocarbon 2,2-dimethyl butane undergoes free radical substitution. In a propagation steps, a free radical is formed. How many different structure of free radicals are formed? Look at here, this is 1 and 2, so 1 2 3. This can be possible, this is possible, this is possible, not possible, and because this is and this is CI3 and CI3 is same, so it is not possible, and over here CI3 and CI3 are same, so this is possible, so that's why 3 different substructure of radicals are possible. Next question is the equation shows a reaction that occurs between carbon monoxide and nitrogen monoxide in a catalytic converter. Which statement is correct? The catalyst used is finely divided iron. No, not finely divided iron. Platinum and palladium. Platinum and palladium used, or platinum rhodium. So these catalysts are used in catalyst used is finely divided in catalytic converter. The reaction prevents greenhouse gas emission into the atmosphere. This is not correct because carbon dioxide is methane gas which is produced in catalytic converter. The reaction reduces the possibility of formation of photochemical smoke. Reaction produces the possibility of, yes, this is correct because nitrogen dioxide, nitrogen monoxide is reduced to nitrogen in catalytic converter CO2. Okay.
7:31 p.m.
The reaction.
Sir, mark message timing. 7:31 शुक्र है आपको मैंने मैसेज किया था वो 3 मेल किए हैं 1 मेल में 100 क्या टाइप में आप रख लें सवाल.
Alkanes. Next question is citrus flavor of lemon is due to the compounds limonene present in both the peel and the juice. What is the mole ratio of carbon dioxide to water produced when limonene is completely burned? We know that the carbon number is 10, so it means 10 carbon dioxide is formed and 8 water molecules are formed. What is the mole ratio? So this is 10:8, and it is when we simplify this ratio it will become 5:4. So B option is correct option. Next question is crude oil is a mixture of many hydrocarbons ranging in size from 1 to 40 carbon atoms per molecule. The alkanes in crude oil can be separated because they have different boiling points. The table below shows the boiling points of the same alkane. Butane. The table below shows the boiling points of the some alkanes. Pentane 36, hexane 69, 86, 2-methyl. What is the correct explanation? What is the correct explanation for the difference in boiling points of the what is the correct explanation for the difference in boiling points of the three isomers with MR72? Boiling point is dependent upon the length of the carbon chain only. No, this is not correct. Increased branches on a carbon atom increases the boiling points. No, increased branching on a carbon chain decreases the boiling point. Decreases the boiling point because surface area to volume ratio is reduced. Increased branching reduces the strength of the intermolecular. No, decreases the surface area, not intermolecular. Hydrogen bonding is absent in alkanes, so that's why increased branching reduces the strength of the intermolecule, but not due to the hydrogen bonding. So increased branches reduces the strength of the intermolecular van der Waals forces. This is correct option. Next MCQ's question. This is all about the alkane. In next portion, in next part, I will discuss alkene.